Imagine a world without cranes, trucks, or even wheels. No engines to pull, no metal tools to cut, and no machines to lift. Now, imagine moving stones weighing up to 20 tons, the size of a small car, across jagged, windswept peaks that rise over 13,000 feet. These are the Andes Mountains, a landscape of sheer cliffs, deep ravines, narrow ledges, and sudden, violent storms. For the Inca civilization, this wasn't an occasional challenge. It was an everyday reality. Entire cities, temples, and fortresses had to be built atop these mountains, and each stone was a critical piece of the puzzle. The Inca didn't just face gravity, they faced the elements. Torrential rains could turn paths into rivers of mud, icy winds could lash at workers, and landslides could wipe out days of labor in an instant. Yet despite these dangers, the Inca not only built, they thrived. Machu Picchu, Ollantaytambo, and Sacsayhuaman stand today as enduring testaments to their skill and determination. But this wasn't just about moving stones. Every stone carried symbolic and spiritual weight. The Inca believed that their architecture connected them to the gods, the mountains, and the earth itself. Precise placement of stones was essential, not just structurally, but spiritually. A misaligned stone could disrupt harmony and offend the deities, potentially bringing misfortune to the city. So, how did they do it? How did human hands, ropes, wooden levers, and sheer ingenuity move objects that modern engineers would struggle to lift even with cranes? The answer lies in a combination of human coordination, environmental understanding, and centuries of accumulated engineering knowledge, a knowledge system encoded into their very mountainside cities. In this video, we're going to follow the Incas' extraordinary methods step by step. From quarries high in the mountains to terraces that cling to cliff edges, we'll explore how a civilization without wheels or iron tools reshaped one of the harshest landscapes on Earth, and why their methods continue to inspire modern engineers today. The Inca Empire wasn't just a collection of cities, it was a sprawling network stretching over 2,500 miles, from the arid deserts of the coast to the frigid highlands of the Andes and the lush tropical valleys below. Every new building project wasn't simply about construction, it was about asserting control, demonstrating power, and maintaining the delicate balance of society. Temples, fortresses, and palaces were symbols of the emperor's authority and the god's favor. Consider this: a single misaligned stone in a fortress wall could compromise the stability of the entire structure. A collapsed terrace could trigger landslides, destroy crops, or endanger lives. For the Inca, moving stones was not a trivial task. It was a matter of survival, prestige, and spiritual harmony. The architecture needed to endure earthquakes, torrential rains, and centuries of erosion. Every stone represented meticulous planning, careful labor coordination, and respect for both human effort and natural forces. The stakes were not merely practical. Inca builders were part of a society deeply tied to religion and cosmology. Cities like Machu Picchu were oriented according to astronomical events, sacred mountains, and water sources. Every stone had to align with these principles. A mistake wasn't just structural, it could disrupt the spiritual balance, offending deities and potentially bringing misfortune to the community. Moreover, the Inca relied on the labor of tens, sometimes hundreds, of people to move a single stone. Coordinating these workers required social cohesion and trust. A failed project didn't just waste materials, it could weaken morale, destabilize a workforce, and even reflect poorly on the ruling elite. Successfully moving and placing stones wasn't just an engineering challenge, it was a social and political one. So, as we begin to explore their methods, it's important to understand that the Inca weren't simply moving stones. They were shaping an empire, aligning with the cosmos, and demonstrating human ingenuity on a monumental scale. The survival of entire cities, the endurance of religious practices, and the legacy of an empire rested on these massive feats of engineering. So, the question remains, how did the Inca move these massive stones without wheels? Draft animals strong enough to pull them? Or metal tools to cut and lift? Archaeologists and historians studying sites like Sacsayhuaman, Ollantaytambo, and Machu Picchu have uncovered a series of ingenious strategies that reveal just how methodical and organized the Inca were. First, quarrying close to construction sites was essential. By cutting stones near where they would eventually be placed, the Inca reduced the risk of damage during transport and minimized the distance labor had to cover. Some quarries were perched high on mountainsides, which may seem counterintuitive, but the natural slope often allowed stones to be moved downhill with control, using gravity to their advantage. Next, transportation techniques included wooden sledges, ropes, and log rollers. Hundreds of workers would coordinate their movements, sliding stones over prepared paths. Logs acted as rollers, allowing stones to inch forward slowly, while ropes allowed teams to apply force in a controlled way. Archaeological experiments show that with wetting or lubricating the ground, friction could be reduced, making even the heaviest stones movable with human labor. The Inca also built terraced ramps and switchbacks, especially when moving stones uphill. These ramps created gradual inclines, distributing weight and reducing strain on workers. Switchbacks allowed stones to be turned around corners or redirected along cliff edges safely. These ramps were carefully engineered to handle the massive load while preventing accidents. Another critical technique was the use of resting platforms. Flat areas carved into slopes allowed workers to pause, reposition stones, and check alignment. These were not mere convenience spots, they were essential safety measures, ensuring that a single mistake wouldn't send tons of stone tumbling down the mountainside. But beyond the physical tools, there was planning and knowledge. The Inca didn't just guess, they tested, adjusted, and coordinated at every step. Smaller stones were moved first to test slopes and ramps. Workers learned the behavior of each stone, gradually increasing the size and weight as experience grew. This iterative approach allowed them to refine methods over generations, combining empirical observation with collective knowledge. So, while it may look like brute force at first glance, it was anything but. The Inca used physics, human coordination, and environmental understanding and harmony. Every stone moved involved careful calculation of slope, friction, and manpower, ensuring both safety and precision. In other words, what we see today at Machu Picchu and Sacsayhuaman isn't luck or brute strength, it's engineered brilliance. The Andes Mountains were relentless opponents. Workers didn't just contend with heavy stones, they faced sheer cliffs, unstable slopes, sudden storms, landslides, and thin air that made every breath a struggle. One misstep could send a stone hurtling hundreds of feet, wiping out weeks of labor and endangering lives. Every move required not just strength, but precision, patience, and teamwork. To overcome these obstacles, the Inca relied on coordinated labor on a massive scale. Hundreds of people often pulled stones simultaneously, following precise rhythms that synchronized their effort. Signals, chants, or other auditory cues may have been used to keep the teams in perfect harmony, ensuring that no one pulled too early or too late. This was not chaos, it was a well-orchestrated operation, guided by experienced leaders and passed down through generations. Measurement and planning without modern tools were critical. Inca builders used rudimentary leveling techniques, sometimes relying on water-filled trenches to ensure flatness, or careful pacing to calculate distances. Trial and error methods tested each slope, ramp, and path before moving the largest stones. They combined empirical observation with knowledge accumulated over generations, learning which slopes created too much friction, which paths were safest, and how to distribute manpower for maximum efficiency. Leverage and counterweight played a key role. Wooden levers allowed stones to be lifted or rotated incrementally, preventing the need to move them in a single, dangerous motion. Teams often worked in shifts, ensuring that energy remained high and coordination precise. Even the natural terrain became part of the strategy. Resting platforms, slight inclines, and gentle slopes were intentionally used to reduce risk and facilitate movement. And yet, even with all these techniques, the process was perilous. Torrential rains could turn trails into slick slides. Freezing temperatures at high altitudes could sap strength. Rocks and boulders might shift unexpectedly. Every stone moved was a calculated gamble. The Inca had to anticipate failures and create contingencies, which meant labor, patience, and ingenuity were just as important as physical strength. This is where the story becomes even more impressive. The Inca weren't just moving stones, they were orchestrating a symphony of human effort, physics, and environmental mastery, ensuring that even the most massive blocks could be transported across mountains without disaster. The stakes were literally life and death, structure and collapse, survival and failure. For centuries, scholars assumed that moving massive Inca stones relied purely on brute strength, but modern archaeological experiments have revealed something much more fascinating. The Inca combined precision, observation, and coordination in ways that even engineers today admire. Experimental archaeologists have recreated Inca stone moving techniques using only ropes, wooden rollers, and manpower. They discovered that precision cutting of stones was essential. Each block was shaped to fit its destination perfectly, often with millimeter accuracy. Before moving the largest stones, smaller test blocks were transported to experiment with slope, friction, and balance, gradually refining the technique over time. The experiments also revealed the importance of incremental adjustments. Stones were rarely lifted or moved in one go. Instead, workers would slide, tilt, and rotate them in controlled steps. Wooden levers acted as fulcrums, and counterweights helped shift even the heaviest blocks safely. This iterative approach prevented catastrophic accidents and ensured each stone could be aligned precisely with its neighbours. Synchronization was another crucial element. Teams of workers coordinated using rhythmic chants or signals, ensuring that everyone pulled and released ropes at exactly the same moment. Misalignment wasn't just inefficient, it could be deadly. Archaeologists were astonished to see that hundreds of people could move massive stones using only muscle, leverage, and timing, proving that ingenuity, not brute force, was the real key. These findings also provide insights into the social organization of the Inca. The coordination required for these projects suggests a highly structured labor system, with leaders directing teams, experience passed down through generations, and communities working together for shared goals. In other words, the Inca weren't just moving stones, they were building society itself through collaboration and careful planning. This revelation challenges long-held assumptions about ancient engineering. The Inca weren't just strong, they were clever, methodical, and adaptive. Each stone moved was a testament to applied physics, collective effort, and the genius of trial and error. While moving stones short distances on a mountainside was already a feat, some Inca blocks travelled over 20 miles from their quarries to construction sites, crossing rivers, valleys, and rugged terrain. How did they do it without wheels or draft animals strong enough to carry such loads? The answer lies in a combination of ingenuity, adaptation, and resourcefulness. One key technique was the use of sledges on prepared paths. By laying down logs, wetting the ground, or lubricating paths with mud or water, friction was reduced, allowing teams of workers to slide even the heaviest stones across uneven terrain. Archaeological evidence suggests these sledges were carefully constructed to match the size and weight of the stone, maximizing stability and control. Crossing rivers and ravines presented another challenge. The Inca built temporary bridges, wooden tracks, and stone platforms to create stable routes. Some rivers were shallow enough to ford with rollers and sledges, while others required creative engineering solutions. Every obstacle became a problem to solve with local materials and ingenuity. The Inca also relied on rotating labor teams. Continuous movement of massive stones required immense energy, so workers were organized into shifts. While one group rested, another kept the stone moving. This system maintained momentum, prevented exhaustion, and minimized errors that could cause catastrophic accidents. Environmental factors were another consideration. Torrential rains, landslides, and sudden temperature changes could halt progress at any moment. The Inca anticipated these conditions, building temporary retaining walls, drainage channels, and support structures along transport routes to safeguard both the stone and the workers. What's remarkable is that no single technique worked alone. Quarrying, sledges, ramps, rest platforms, bridges, and labour rotation all had to be used in concert. Only by integrating these strategies could stones traverse vast distances safely and arrive ready for precise placement in monumental structures. This isn't just engineering, it's a masterclass in problem solving, human coordination, and environmental adaptation. The Inca transformed a seemingly impossible challenge into a carefully choreographed process that became the backbone of their civilization's architectural achievements. The ultimate testament to Inca engineering is Machu Picchu. Perched on a narrow ridge 7,970 feet above sea level, this city is a masterpiece of design, precision, and resilience. Every stone, every terrace, every wall reflects centuries of accumulated knowledge, environmental awareness, and meticulous planning. What makes Machu Picchu truly astonishing is that no mortar was used, yet the walls have survived earthquakes, torrential rains, and centuries of erosion. How? The Inca employed a technique known as ashlar masonry, cutting stone so precisely that they interlock perfectly. Gravity and friction hold them in place, absorbing seismic shocks rather than resisting them rigidly. During an earthquake, the walls can move slightly and then settle back, preventing collapse. Terraces were another critical innovation. Not only did they prevent landslides and soil erosion, but they also distributed the weight of structures on steep slopes. Water runoff was carefully managed through drainage channels, preventing flooding or damage. The combination of terraces, interlocking stones, and precise construction demonstrates the Inca mastery of engineering in harmony with nature. But it wasn't just structural ingenuity, it was social and organizational brilliance, coordinating hundreds of workers to move massive stones, shape them to exact specifications, and place them safely on precarious slopes required leadership, planning, and communication. The Inca transformed the challenges of the Andes into a framework for monumental achievement. Machu Picchu and other Inca sites like Ollantaytambo and Sacsayhuaman reveal a civilization that didn't merely survive in harsh environments. They thrived, mastering the mountains and turning obstacles into opportunities. Every terrace, wall, and temple tells a story of human determination, ingenuity, and the ability to work with nature rather than against it. This is the climax of the Inca story, the realization that massive feats of engineering, seemingly impossible to us today, were achieved with intelligence, collaboration, and a deep understanding of their environment. It's a triumph of human creativity, endurance, and adaptation. As we step back from the mountains of Peru and look at the towering walls of Machu Picchu, we begin to understand the genius of the Inca. These weren't just builders moving stones, they were master planners, problem solvers, and innovators who turned extreme challenges into opportunities. Their achievements teach us that human ingenuity thrives under constraint. Without modern machinery, without iron tools or wheels, they discovered solutions that combined physics, teamwork, and environmental adaptation. Each terrace, ramp, and interlocking stone was the result of centuries of trial, error, and refinement. The Inca remind us that engineering is more than technology. It's about strategy, coordination, and harmony with nature. Modern engineers still study their techniques to understand earthquake-resistant construction, sustainable land use, and logistical problem solving. The lessons of Machu Picchu resonate today because they are timeless. Careful observation, creativity, and collaboration can overcome even the most formidable obstacles. And perhaps the most inspiring lesson is the social dimension. Large-scale projects weren't possible without trust, leadership, and a shared vision. The Inca show that ingenuity isn't just individual, it's collective. When people work together, incredible things become possible. So, next time you marvel at Machu Picchu or Sacsayhuaman, remember that every stone tells a story of adaptation, perseverance, and brilliance that allowed an empire to rise in one of the harshest environments on Earth. These lessons echo far beyond the mountains of Peru, reminding us that with intelligence, coordination, and courage, humans can achieve the extraordinary. What ancient engineering feat do you think is even more impressive than Machu Picchu? Let me know in the comments. If you enjoyed this journey into human ingenuity, hit subscribe for more essential survival skills and inventions.